So question 4 is about background radiation and interpreting data, and a bit of how science works stuff about surveys and how you can get better results, or why you would choose to do surveys in different ways depending on the circumstances. So the first question is just being able to add up. But the thing that people miss on this one is it says, what is the total radiation dose the average person in the UK receives? And it's giving you these units called millisieverts. And you just add up all the things in the pie chart, but this is the one that people miss, the 0.01 millisieverts. That has to be up there and not actually written in the pie chart, because obviously that slice is so tiny that you can't see it. So 2.5 is the answer, not 2.49. For a part 2, which of the following statements is true? From this data as well. I mean, they may be true, but it has to be a correct conclusion from this data. Very important that you refer to the pie chart and not just to other knowledge you may have. In the future, more people will be exposed to a greater proportion of radon gas. Well, that's not true really in general. Right? People that have never had an X-ray get 50% of their radiation dose from radon gas. Well, again, that's not what the pie chart says. So the last option, the radiation dose from natural sources is much greater than from artificial sources. If we look at the pie chart, right, the artificial sources on the pie chart are medical and nuclear weapons testing, nuclear accidents and power stations. So this part of the pie chart here, about an eighth of it, and the rest of it is all natural. So that is the one that is correct. Radiation dose from natural sources is much greater than from artificial sources. 4b. So this is the section of the question that's about this survey of homes to see what the radon levels are in the homes. Okay, so the first part says each year 1,000 to 2,000 people die because of the effects of radiation from radon gas. Why is it not possible? Okay, why is it not possible to give a more exact figure than that? Well, the main reason is that it's impossible to attribute those deaths to radon with 100% certainty. It could be something else. So other factors may be involved are sufficient. And if you suggest a specific factor, that's fine. And if you suggest that you can't be sure that radon exposure has caused the death, that is fine. Okay, so that's fairly straightforward. Now, 4b part 2. The table gives data for the radiation levels measured in different homes in 4 different parts of the UK. 2 detectors, one in the living room, one in the bedroom, measurements taken over 3 months. Okay, very important again to read the information about the experiment and not just dive straight into the question. Give one reason why the measurements were taken over 3 months using detectors in different rooms. So you could have, there are 2 alternatives here. You could focus on the 3 months part and say, well, averaging over 3 months will average out daily fluctuations, so it might change from day to day. And the different rooms part would possibly be that there might be different concentrations in different rooms, especially given the bedroom is likely to be on the first floor and the living room likely to be on the ground floor. You don't probably know enough about radon to be certain as to whether it would accumulate in the bottom of the house or in the top. So you've got to have both of those things in there. You're allowed to say find an average, make it more valid or reliable, but not more accurate on its own. Very rarely will you get credit for saying it makes the results more accurate. Okay, reliable and valid are allowed because they are actually what's going on. Increasing the number of samples that you take in any way will make your results more reliable. So using the 2 detectors and using the long period of time will make your results more reliable. And generally speaking, the more reliable are, the more valid they are. So the more they are a true reflection of what is actually going on. And what the typical radon levels might be in those 4 areas. Now, 4b part 2, 2 marks here. Use information from the table to suggest why a much higher proportion of homes were sampled in areas C and D than in areas A and B. So, the only 3 columns you could look at here, which have not been used, is the number of homes in the area, the average level, and the maximum level. And really, if you're trying to find out if particular homes are affected, then if you have high average levels and some homes with a very high level here, maximum level extremely high, then you need to do more samples to check which homes it is that have the really high radiation levels. So they allowed that the average level was much higher in C and D, so you're probably going to want to do more samples to see which are the homes with very high levels, and the maximum levels are very high in C and D. So literally all you had to do was to write down the key features of regions C and D from the table. Okay, the column we didn't care about was number of homes. That's not really important for making a decision. I mean, you should probably sample a roughly equal proportion of homes. You can kind of see that in this part here. We had 160 from 590,000 and a slightly smaller number, 130 from the 484,000. They've done most homes in Region C because that has extremely high maximum levels and the highest average levels. So that's how you get the marks there.